All right, today we're going to learn everything there is to know in computer science, almost. And we're going to learn a new programming language for some of you guys called Python, which is an extremely popular programming language, considered easy to learn for beginners. And spoiler alert, what you're going to be doing is completing a learning path on Microsoft, which looks like this. Getting started with Python. Let's see here. Go back to here. Okay. And Python for beginners. Okay. And this is up on Canvas. What you're going to be doing is you are going to go to this website and you're going to go through the whole thing. And as you complete parts of it, you'll get these green checks. When you complete an entire section, there's going to be a little check for knowledge at the end of it. What's the main version of Python? Python 3. How do you display information on the screen? Print. What extension is used? Py. Check your answers. Boom. Correct. Hit continue, and you get experience points for doing it. So as you complete sections, like when the whole section's complete, you get all the green check marks. You get 900 XP. Your goal is to get all 10,200 XP for this thing by next Thursday at midnight. So you have 1 week to learn an entire programming language. In fact, we're gonna get through most of it today because it's not too bad. Okay. So what I'm looking for from you guys is a screenshot showing that you have completed this entire thing. It is estimated to take about 3 hours. I've already completed some of it. So it's about three hours and change to do the whole thing. That said, don't start at like 9 p.m. at night. You're going to be shorting yourself. This is something that you probably want to spend some time doing. It's a great learning path. For those of you who are experienced in Python already, then we're going to do this one for you guys instead, which is going to teach you about NumPy and pandas and things like that. And so you will learn how to do like number analysis and make bar charts and things like that. Kind of the basics of data science. And so let's see if we can get a graph here. There we go. And so for those of you that have programmed before, you're going to do this learning path here, and it's gonna be fun. It'll be good. It'll be fun for you guys. So you're gonna start off by installing Visual Studio Code, and if this sounds like staggeringly hard to you, the good news is it gives you like just step-by-step directions for everything. Okay. And so you click here, you click on that, and you click on this, and you click on that, and it has screenshots for everything. You do this, you click here, has all the links you need. You click here, you go to extensions, and click on Python, click install. It walks you through everything. Like it's very hard to fail this assignment because it has directions for everything. The quizzes can be retaken, all that kind of stuff, and it's just a really easy and straightforward way of learning Python. I like it. I like it a lot, despite it being from Microsoft. Okay. So the weird thing about computer science is that you can actually describe all of computer science in about an hour. And that's what we're going to do today with the context of the Python programming language. There's only about 6 things you need to know in computer science in order to be able to write any program in computer science. Maybe 7, maybe 8, maybe 9, but not that many. It's just there's really not that many things, which kind of startles people sometimes because computer science is a huge field. It takes 4 years, to get your bachelor's degree in computer science. How the hell does it take 4 years when you can explain all of the concepts, and they're not that bad, I don't think, when you can explain all of them in about an hour to somebody who's had no more math than algebra. Maybe a bit of trig, but pretty much algebra. Okay? I don't think we're doing any trig today, just algebra. So, this is it. This is all of computer science. Like you have to know how to make variables. You have to know how to do input and output. Okay, we're going to go through each one of these, but like once you know those 6 things, those big concepts, what's really interesting is that when somebody gives you a new programming language, right? You go to work for a company, and let's say you're an expert at this point in Java and Python and C++. You go to work for a new company, and they're like, "We're doing Ada." Uh, Ada is the name of a programming language named after Ada Lovelace, the world's first computer scientist. It was popular in the military. There was a language called Ada. And so you go to work for a company. Like one of my former students is now working on the software for aircraft carriers. And let's just say, I don't even know if they use Ada, but like, let's just say you show up and they're like, we do Ada here. You might think like, oh, geez, oh no. Like it took me a year to learn computer science. It took me a year to, learn C++. It'll take me a year before I know Ada. But an experienced computer science person will simply be like, okay, show me how to do these 6 things: variables, algebra, IO, conditionals, branches, loops, and functions. Show me how to do these 6 things in Ada, and now I kind of know the language. Like there's always going to be sharp edges that'll cut you and things like that. But basically, if you can show me those 6 things in a language, I can learn a language in about a day, maybe less. I used to think it was like ridiculously like impossible to learn a new language so fast. And then I took a languages class in my junior year of college, and we learned another programming language every week. 10-week class, 10 languages, basically. Maybe there was not one during finals week or something. I don't know. But basically every week we were learning a new language. We're learning Algol 60 this week, a programming language from back in 1960. We're going to learn Camel this week. And we did. And not only did we learn a new language in a week, we would write programs in it, like doing like calculus and things like that in like a week. And then next week, we're learning Pascal, and we're going to do Riemann sums in Pascal. And okay, next week we're learning. And after a while, like you realize, you come to this sort of like enlightened state of like realization that all languages are the same, even though they're all different. Especially functional languages are kind of different, but you sort of reach a sort of like enlightened giant big brain meme kind of thing where you're like, all I need to do is learn these 6 things, and then I've kind of got it. And there's always weird things about every language, and there's always different ways they approach problems and things like that. But okay, so here we go. So this is how I always break things down for my students. Start off with the variables. Okay, so variables are very easy to make in Python. So for example, if you say x equals 5, this creates a variable named x and sets its value equal to 5. So I will switch over to a interactive prompt here, and you're going to learn how to do that through that learning path. And I can just start typing code. Like I don't have to have source code or a compiler or any of this stuff. I can actually just type code interactively into the Python prompt. And if I want to see what the value of x is, I can just type x, and it'll print the value of 5. If I set y equal to 2, print the value of y. Or I can print it like this if I wanted. Now, I could also set, Bob equal to hello world. And so if you put double quotes around something, that makes it a string, which is to say words. And if I were to print Bob, it will print hello world to the screen, which is your traditional first program in computer science. I'm not really sure why that's the traditional first program. It probably dates back to like Carnegie and Ritchie or something like that. But the sad thing is, no matter how many times we say hello world, the world never says hello back. It just puts us on scene. So, yeah, those are variables. Pretty easy. In C++, it's a little bit more intensive to make a variable. Here, we just say, hey, this variable exists, and it's equal to 5. Okay, cool. What if we tried using a variable that doesn't exist? It'll tell you z is not defined. Okay. So next up, we got algebra. So if we say, remember the value of x is 5, value of y is 2, what do you guys think it's going to print? Spoiler alert. What do you think it's going to print if I say x plus y? Anyone want to take a crack at this highly advanced algebraic statement? You're right. Okay. All right. Let's make this a little more complicated. Let's say x is equal to 17 and y is equal to 4. What is x minus y? Abraham Lincoln. 21. Interesting. Yeah, it is in fact 13. At least I hope so. There we go. Good. I always like running my code just to double check. Like for something simple like this, like I could be pretty confident. Error. But it's always good to actually run your code and test it because I make mistakes too. We're all humans here. Okay. So x is equal to 9. Y is equal to 4. What is x times y? X times y. Indeed, it is 36. All right. What operation have I not done yet? I've done plus. I've done minus. 20. Which one am I missing? Division. So, this is an interesting question. Is this going to do floating point division, or is it going to do integer division? And in C++, if you did this, it would do what's called integer division. It would only give you a whole number. If you guys remember 4th grade, how many times does 6 divide into 20? How many times does 6 divide into 20 with a remainder of what? Do you guys remember that back in the day doing long division? Nobody, like, in real life, like, you just basically kind of very rarely do long division, you know what I mean? Usually you just punch it into a calculator and it'll give you 3.66, something like that. 3.3, sorry. And the long division approach, though, in Python involves 2 slashes. So if you do 2 slashes, it'll give you a 3. And if you want to get the remainder out of it, you use modulus, which is the percentage sign. A lot of students think this means percentage. It doesn't. This means something called modulus. Modulus is the remainder operator. And so 6 divides into 20 3 times with a remainder of 2. Okay? So you should probably write down these 3 things here. Because that's something that that is something that making sure you get this one right. Like, do you want to do integer division? Do you want to do floating point division? Like, that's you need to make sure that you're doing the right one. Because if you do the wrong one, your code's going to be kind of wonky. Okay. So there's also exponentiation. So if we have x is equal to 5, y is equal to 2, x times y, this is exponentiation. Okay. And that is 25. So that is 5 to the 2nd power, 5 squared. Okay. So single division, single slash is floating point division. Double slash is integer division. 1 multiply is multiply. 2 multiplies is exponentiation. And percentage is modulus. And that's about the hardest thing you're going to learn today. So just make sure you write those down. I think it's in the thing here. Yeah. So that. and that. Okay, yeah. So it's all in the slides, and the slides are like 9 pages long. Okay. Next up, we have input and output, and so the print function prints things to the screen, hence the name. So if I said print x, it prints 5, or you just type x if you want. What would happen if I say print x plus y? What is that going to print to the screen? What do you guys think? Highly advanced algebra we're doing here, people. Highly advanced. It does print 7. Okay, good. So that's how you print things to the screen. You can either just write an expression like that and it'll print the result, or you can use the print function to print things to the screen as well. So how do you do input? How do you get a value? You can say x is equal to input, like this, input, like that. And now it's going to wait. This is how you read from the keyboard, okay? And so I'm going to type in 5, and then if I print the value of x, you can see it's 5, but it's got these weird single quotes. Huh. And if I say y is equal to input, read a string keyboard. So what's happening here? I type in 2, you can see that y is 2. So if I were to print the value of x plus y, what do you think is going to get printed to the screen? Yeah, you think 7, right? 52. Now this is one of the few sharp edges in Python. Python doesn't have they're called variable types, and so you can kind of hack it together a little bit. But basically, like when you do this, it figures out what type x should be from the right-hand side. So it figures out, because input always returns a string, then x is now a string. A string is a word, right? So if I said x equal to input, shoot, and I typed in hello, x is hello, get the quotes around it. Y is still 2, and so if I outputted x plus y, we get hello 2, and that might make it clear what's happening here. If we make y equal to world, y equal to world, and then we set x plus y, now it's hello world. Anytime you do addition with words, it just concatenates them together. So if x is hello, y is world, x plus y is hello world. And that's why when we added 5 plus 2, we got 52. Okay, they're strings, yes. So that is a very common mistake that people make in Python, and the way that you fix it is by doing a little dance here. And this is going to read in the input, and it's going to convert it to an integer. So if we type in 5 now, there's no single quotes around it, right? It's now actually the number 5. And if we say y is equal to input, then y is actually 2 now, not the word 2. If that makes sense. And so x plus y, I keep typing 7 there, is now 7. Okay, so so the third thing in computer science, there's only 6, right? The first thing's variables, just x equals 5, y equals Billicarney, whatever. Your algebra stuff, add, subtract, multiply, divide, exponentiation, and modulus. Input, it's just you type input like that. Print things with print. Okay, next up are conditionals. So we're already halfway through an entire bachelor's degree in computer science in just 20 minutes. Okay. Next up is conditionals. And so a conditional means we're either going to do one thing or another. So for example, if you input like the grade of a student, if you do like x is equal to input, int input, and you want to tell your students if you're passing the class or not, You can write a code that says if x is greater than or equal to 70, print you passed. Otherwise, print you failed. Now, this is an important thing in Python. Every time you indent something like this, it's always 4 spaces. And if you get your space indentation wrong, you should switch your major. Is this too easy for you, Vince? You didn't realize that you can learn everything in computer science in 1 hour? Are you going to switch to computer science or away from computer science? Tabs versus spaces. I know, right? I am definitely a tabs person, but the Python people are hardcore spaces people. So, for example, we can do something like this, like grade is equal to int input, and they'll type in I'm getting a 91 in the class. And then you can do something like this. You can say if grade is greater than or equal to 90, and then the interactive prompt turns into a ... Now I have to go 1, 2, 3, 4, print you have an A. And then you can have an elif. Grade is over 80. If I screw up any of the spaces on here, everything's going to explode. You have a B, and I can go down the line with this. I'm just going to type Control D, and you can see that because my grade is 91, I have an A. Okay. We're already through halfway through a bachelor's degree. It's that easy. Now, the hard thing is the problem solving, right? The hard part is not actually learning to program. Like a lot of people think you're going to spend 4 years learning to program in a bachelor's program in computer science, but you don't. You really don't. Like you're learning like here's one of the Rough Garden books, Algorithms Illuminated. If I open it to a random page, how do I find, given a set of points on a number line, how do I find which 2 points are closest to each other? Open it to another one. Finding the maximum value in a data sequence. Merge sort, how do you sort numbers? How do you tell how long things are going to run? And that's a big thing, actually, like determining the running time of things. Is this algorithm faster than another algorithm? That's a big part of computer science, too. It's not really learning to program. Like, there's a bit of it. Learning to program. But a lot of people think that, like, learning to program is computer science. It's really not. It's just almost kind of a small part of it. You have to know how to program. If you don't know how to program, you're going to potato hard. Like, hard. It's not good if you don't know how to program in computer science. But it's really just maybe the first year you're learning to program. And then after that, you just kind of work on your skills and you work on your problem solving. You work on, all right, how do I break problems down? And how do I attack problems in different ways? And how do I work with other people? That's a big one. My goodness, friendship is the hardest thing in the world in computer science. Recursion. Yeah, you break something down using recursion. Like that's the hard part in computer science. Like you're going to have your mind melted any number of times by these algorithms and things like that. You're like, what? That's impossible. It's not really learning to program. Okay. Elif, you know how to say A in Arabic. I did not know that. That's cool. Very cool. So, yeah, that would be in this section here, I think. Yeah, okay. Elif. Okay. Neat. Okay. Next up is loops. And so, I kind of want to put for loops in there, but I decided to just do while loops instead. The simplest while loop is a while true loop. And so as long as this conditional is true, which it always will be, it'll run the code inside of the loop body. And so loops mean do some code over and over. Repeat. In other words. Okay. And so this code will never end. This is an infinite loop. Okay. All right. And I already have it down here. Okay. Control C will cancel. So if you're in an infinite loop, so let's do that. While true, 2, 3, 4, print, help me, I am stuck in a program. Control D runs forever. Control C stops the infinite loop. All right, so yeah, so branches say do one thing or another. That's where all of the intelligence in your program comes from. And then a loop allows you to repeat something. And the last thing, and we're only 26 minutes in, the last thing is a function. So for conditionals, there's if, there's else, and there's elif. So maybe we'll do this. Elif, don't capitalize for me, x equals 70. You are borderline. Okay. So if, elif, and else. If, else, if, else. And with that, you can basically have the code go one way, have code go another way. You can make more complicated if statements. You can say, like, if the humidity is above 80% and wind speed is below 20, and yeah, you're going to practice a lot, like, for sure. But, like, this is just kind of a summary of, like, all the things. So you can make these things quite complicated, and you can make, you can make, like, a branch for, like, getting an A, and a branch for getting a B, and a branch for getting a C, and a branch for getting a D, and an F, unfortunately. And so these things can grow quite complicated. Like, I'm not downplaying, like, how much, like, brain power and effort and sweat it takes to get a bachelor's in computer science. I'm just saying, like, the core concepts themselves are, like, yeah, like 20 minutes. About it. Practicing would be good, yeah. So maybe we'll do a little bit of that. And then loops, just repeating something over and over again. So for example, you can make it print hello world 10 times. And then finally, last thing is functions. And so a function, if you guys remember, like algebra, if you want to make a function like f of x is equal to 2x, so you take an input and you return twice the value. You do it like this in Python. You say define a function named f of x, and you return 2 times x. That's it. And then later on in your code, you can just say f of 10, and it prints 20. F of 40 gives you 80. Okay. So it's going to look something like this. So we're going to define f of x, 1, 2, 3, 4. Be return 2 times x, like that. Control D to get out of that. And then if I just say f of 10, we get 20. If I say f of 100, I get 200. If I set x is equal to f of 50, what value does x have? F of x? Very good. Yep, the value of x is 100. Okay. So, you make, and again, these things can grow quite complicated. This is about as simple as a function as you get. But that's the basic idea, is that you just say, I'm going to make a new function called f of x. And does it have to be called f? No. This isn't math. We're not required to use f and g for literally every function ever made. we can do other things. And there's some that are built in. For example, if we set x equal to the absolute value of negative 123, what value do you guys think x has now? Yes, 123, very good. Yeah, 246, interesting. No, I could have done that. I could have done like f of 123. Right. Now we got 246. So yeah, some of these functions are built in, and some of them you can just write yourself. And with these things, you can kind of do whatever, and they can grow complicated. They really can. But this is, I try to show the simple things to begin with. So I don't know. Let's define grade. I don't have to call it f. Look at this. It's crazy. Look at this, math people. I can make a function not called not called f of x. It's amazing. Okay, 1, 2, 3, 4. If x is greater than or equal to no parentheses. You will see me type C++. Trust me. If x is greater than or equal to 90, then 1, 2, 3, 4. 1, 2, 3, 4. Look at this. We're 8, and now print. You get an A. No semicolon. Not C++. Okay. 1, 2, 3, 4. Elif x is greater than or equal to 80. Print. You get a B. No semicolon. 4. Elif x greater than or equal to 70. You guys getting the pattern here? All right. Ah! Death. This is why you write source code, by the way, instead of doing it interactively. But you can write Python code just interactively like this. Like, you can just use it as a calculator. You can be like, all right, x equal to 10, y is equal to 22, 10 to the 22nd power is that. Like, you can just use it. Like, you can definitely use Python interactively where you're just typing code like I'm doing here. Normally, though, you're going to actually have a program, and you're going to run the program. And like you have like a text file that has all the stuff in it, so that if you screw up like this, you're not facing death. All right, let's try this again. All right. Gosh. And if I copy the wrong number of spaces, it's going to yell at me. Let's make sure I copy these things right. 1, 2, 3, 4. No. No. I think I did this wrong. Yep. Damn it. This is why you put it into a text file. One more time, I'll just type this. Define grade x, colon, 1, 2, 3, 4, if x is greater than or equal to 90. 2, 3, 4, 1, 2, 3, 4, print, you get an A. 2, 3, 4, if elif x is greater than or equal to 80. 4, 1, 2, 3, 4, print, you get a B. 4, elif x is greater than or equal to 70. 3, 4, 1, 2, 3, 4, print, you get a C. 3, 4, elif x is greater than or equal to 60. 3, 4, 1, 2, 3, 4, print, you get a D. And then for the last one, what do I write? Do you think I should write if? Should I write elif, or should I write else? So if executes if the conditional is true, else executes if none of the above conditionals were true. What do you think? Else. So else means if none of the people above, and I don't put any conditional here, right? I don't have any x's less than or equal. I just say else. So if this is false, and this is false, and this is false, and this is false, the else block will run. 1, 2, 3, 4, 1, 2, 3, 4, print, press F to pay the specs. Okay, now did I type all this right? Let's find out. Control D, yay, all right, go me. So the way that this works, so if I call, hey, give me a grade, and I punch in 90, something like that, what happens is that it goes through this one line at a time. So it jumps up to the function. X is set equal to 90. It says, is x greater than or equal to 90? Yes, it is. Okay, great. So it prints this. And then all of these else things don't run at all. And the reason why they don't run at all is because they say else. So if you do one thing, then you don't do the else block. Only if x was less than 90, then it moves on to the next one and checks this one. So if I do like grade 70, when we come in here, is 70 greater than or equal to 90? No. So then it moves on to the else block. Is x greater than or equal to 80? No. So it moves on to this one. Is x greater than or equal to 70? Yes, it is. Print C, and it skips the rest. So when you have an if, else 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 block, it will run one and exactly one of those branches. Okay. Now, if I had done this with all if statements, if I had gone rid of the L here and just said if, then when I said grade 70, this would be false. This would be false. That would be true. That would be true. And I don't know what I have here, but it would print out C, D, and maybe F. So if this was just if, and this was if, and this was if, and this was if I put a 90, that would be true at print A. That would be true at print B. So when you want to have sort of like mutually exclusive options, like in this case, there's 5 options for a grade. I'm not sure what happened to the letter grade of E, but it doesn't exist as far as I can tell. You have five options, and exactly one of them will run. Every time you punch in a grade here, you got 9% of the class, then you get a F to pay respects. It will print exactly one of those things. No more, no less. The counting shall be 1. Okay. That's Python. I don't really have anything else to say. You want to see some more examples? Let's see if there's anything in here. Lists are kind of cool. You want to see more? All right. Then we'll move on to number 7, lists. All right. So let's say that you're trying to have an early day today. Okay, well, I'll show you lists and then we'll call it. All right. By the way, the previous class voted to have the midterm take place over spring break. So you guys got off next Friday for Cesar Chavez Day. So I'm going to issue you guys the midterm 2 on Wednesday. And then you'll have all 9 days or whatever on spring break to do the midterm. It'll be due before you come back. Okay? So what should we do with lists? Let's see if we can come up with the average. Let's do this. Let's see. Grades is equal to so one student got a 90% of the class, one student got 100%. Look at all these good students. One almost got an A but failed. 78, 110. They did a lot of extra credit. 92, 88. Okay, so these are the grades of students in the class. All right, and you want to find out who is the best student in the class. Best student in the class got 110. Okay, who's the worst student in the class? Well, they got a 78%. Not too bad, honestly. Not too bad. If that was my class in real life, I would be more than happy with it. First week of April is, yeah. So spring break is April 4th to 7th, but you get Cesar Chavez Day off. So you get like a really long spring break. You have like off, I guess, like 10 days total. I don't know. Depends how you count it. So, so what if we just wanted to print all of the grades? We could do this, right? Just print everything. What if we wanted to like add them all up? We could do something like this. We could say sum is equal to 0, and then we could say for every grade. Oh shoot, we got a function in grade. For every variable x in grades 4, sum is equal to sum plus x, no semicolon. And there we go. And so what this is going to do is it's going to say for every variable x in grades, the first time through this loop, x is equal to 90. Next time through the loop, x is equal to 100. And every time, what do? We add that value to sum. Okay? So if I were to print the value of sum now, you can see the value is 647. Okay? And that's basically how you can do a for loop to loop over a list of things like that. If you want to get the average, you can divide by the size of the list like that. And yeah, like there's a lot of data science kind of things like that. that you can do, where you just grab the max, the minimum, the average, I don't know, mean, median, mode, things like that. You can grab the first two elements out of a list like that. Grades 3 to 7, 3 to 6. I'm going to give you 3, 4, 5. Grades 2 and up. So you can select chunks of the list if you want. Grades.sort. We'll put them in order. I don't know. Kind of useful stuff. It's helpful for keeping track of large amounts of data. Really, though, I kind of want, the reason why I'm kind of being vague on this is because I kind of want the more advanced students doing this kind of stuff. So the people that have done Python before, you're going to do the data science thing, and then you're going to learn how to like visualize this and do graphs and things like that. New students who have never programmed before, you're going to kind of see these a little bit, but yeah, don't worry too much about this. This is maybe a little advanced. I don't know. Okay, so I'll just toss this on here. Yeah, but basically with what you know now, that's kind of everything. Everything computer science. Yeah. For x in grades, 0, x in grades, colon, 4, sum plus x. Adds up the numbers. Okay, that's it. You guys know Python now. You guys know everything there is in computer science. Please proceed to the Provost's office and pick up your bachelor's degree. That's about all there is. So, yeah. I guess we'll end it here. I'll see you guys on Monday. So you guys got till next Thursday to finish this at midnight. And if you have any questions, post on Discord. Python's pretty easy. There are some sharp edges. Especially like with the input thing we talked about here. Let's see if I can dark mode this. Why? No, I don't know. Especially with input, like that whole integer thing, something to watch out for. But by and large, Python has got a reputation for being an easy to learn language for a reason, because it is actually pretty easy. Okay, that's it for now. See you guys on Monday. Peace.